Say hi to my little crab. I love feeding him. I love his creepy little hands. He's just the best. So I realized that in this aquarium that I built in my greenhouse, I have accidentally recreated the origins of all terrestrial life on this planet. That is, life on land. Because in here we see sort of a recreation of the very, very first dirt. The very first soil that gave rise to all of the plants that grow up and provide us with all of the wonderful food that we consume. That all comes from that brown sludge, the first dirt. And what is it? Well, broadly it's biomass, kind of a living film of mostly bacteria, but more specifically it's probably mostly cyanobacteria. Cyanobacteria are so named because they're kind of blue-green when you look at them under a microscope. And why are they blue-green? Because those bacteria contain chlorophyll and other molecules that allow them to do photosynthesis, just like plants. They're bacteria that can do photosynthesis, convert the energy from the sun into sugars to eat. They can make their own food with the sun and carbon from the environment. And nobody knows for sure because nobody was there, but scientists think that probably the first mass explosion of life on land on this planet was cyanobacteria creeping up over the rocks that were on the edge of the water. Life, of course, emerged first in the oceans on the planet, and let's talk about why. This is going to be a gross oversimplification of a disputed basic scientific theory of the origins of all life. What is life? Life is basically just a self-perpetuating chemical reaction, similar to fire. Indeed, you could think of fire as being sort of not alive, but kind of life-adjacent. And the metabolic processes that go on in our bodies all the time when we eat food basically are fire, right? Water on Earth about 3.5 billion years ago created the conditions necessary for incredibly rapid and complex chemical reactions to unfold. And with the million monkeys typing at the million typewriters for millions of years, the result was that eventually some of those chemical reactions ended up becoming self-sustaining, just by accident. And why did they stick around? Because they're self-sustaining, right? It's kind of a survivor bias. That's why they're still here, is because they happen to be self-sustaining and they sustain through reproduction, all of the normal processes by which life goes on. Water is an ideal medium for those kinds of incredibly complex chemical reactions to unfold, in part because it is fluid, and it can hold lots of different solutes in it, right? So all of these different chemicals and elements can kind of swim around in this highly mobile environment and bump into each other and combine into things that eventually became like proteins and cells and you and me. Contrast that to the terrestrial surface of the early Earth, which would have just been rock, right? Like lava that had cooled down and solidified. It was just solid rock is what we had on land. Very gradually, over the first couple of billion years of the Earth's existence, what they call weathering occurred, where the wind and the rain, both physically and chemically, wears down the rock and dissolves it into teeny little bits of like sand and then silt and clay and even smaller little bits. And the result is like clay deposits like these kaolin deposits that had been mined here in Georgia, where I got this footage. The rain carried all of those teeny tiny little bits of rock down to the sea through rivers, right? And in that sort of marginal space, the space between the river and the sea, is where we first started to probably see life emerging up onto land, coming up out of the oceans, because they could reach all of those dissolved minerals and use them as nutrients to form the building blocks of themselves. And those first pioneer life forms were probably cyanobacteria, also commonly known as blue-green algae. Cyanobacteria can occur as like single-cell, free-floating organisms in the water, but when they get up on land, they'll generally occur in these big mats, just gigantic colonies, basically of solid bacteria. Hanging out in a big colonial mat like that probably allowed the cyanobacteria to avoid desiccation out here in the open air, to avoid drying out. And they feasted on the sun, they feasted on the minerals that were dissolved and available in those marginal zones where the rivers emptied into the sea. They were also able to free more minerals up from solid rock by dissolving them out of the solid rock with organic acids and such. And that contributed to more weathering of the rock, breakdown of the rock, and liberation of crucial minerals from the rock. And as generation after generation after generation of these cyanobacteria lived and died on these rocky surfaces, very similar to the ones you see on my crab raft in here, as they lived and died, they built up. Their dead bodies just kind of accumulated and mixed with all of those dissolved minerals from the rock. And what is that? That's soil. What is dirt? What is soil? It's old dead stuff, decaying organic matter, previously alive stuff, mixed in with sand, silt, minerals, metals, things that came from the rocky surface that dominated the Earth in the beginning. In the beginning. All of that mixed with the decaying organic matter, and also got kind of mixed around such that there was air in it, right? Especially once we got burrowing animals, but I'm getting ahead of myself. I'm really thirsty. I'll be right back. Oh man, I have totally converted to the cold coffee cult, thanks to the good people at Trade Coffee, sponsor of this video. Oh yes. Trade is the way that I discover all kinds of wonderful coffees from the best independent roasters across the United States. And in the heat of the summer this year, they have been sending me some cold coffees, like cans of cold brew, which is a fantastic product, but also some iced coffee kits. Iced coffee is hot brewed coffee that you then chill down. How do you chill down hot coffee really rapidly such that you can enjoy it, minutes from the time you brew it? Let me show you. This is the Cold Wave iced coffee kit. You take out this core thingy and you put it in your freezer and you just leave it there, and then when you're ready to have coffee, you brew as usual. You can do 2 cups at a time with the Cold Wave, and that's why I'm doing so much right now. Then you pour it into this little pitcher, and then you take the core out of the freezer, and the core is basically just some very dense thermally conductive material arranged in an array with tons and tons of surface area. So you just drop it in really rapidly. The heat from the coffee transfers into that frozen core, and the coffee is left really, really cold and delicious. Ridiculously refreshing in the heat. Unlock the freshest coffee experience for your summer sips. Head to drinktrade.com/Ragusia to shop their full cold coffee collection. Plus, you can subscribe today and save 30% off your first order at drinktrade.com/Ragusia. That's my link, drinktrade.com/Ragusia. Thank you, Trade. Anyway, about 3.5 billion years ago, this yucky sludge started to creep up from the oceans onto the land, and as it died, it built up the first layers of soil on our planet. These cyanobacteria also combined with fungi, also coming from the oceans, to create the first lichens. Lichens are mutualistic colonies of photosynthesizing cyanobacteria and funguses. This is British soldier lichen that I saw at my father-in-law's place in the mountains. So-called because it looks like redcoats. The thing about lichens is that they're even better at dissolving solid rock in order to get crucial mineral nutrients out of it, and so they contributed even more to the development of those first layers of soil. But there was a problem. See, photosynthesis creates oxygen as its waste product, its byproduct, right? And we think of that as being a good thing because we are organisms that are evolved for an oxygen-rich atmosphere, but the first land organisms were not, because there was very little free oxygen in the atmosphere at the time. So the first cyanobacteria species were anaerobic. And as they lived and died and lived and died and lived and died over a few 100 million years, their waste products built up in the atmosphere. That's how Earth's atmosphere got oxygenated in the first place. And it was basically like they killed themselves with their own waste products. Oxygen was toxic to them. Oxygen oxidizes, which basically just means it's a highly, highly reactive element, and that's why it's involved in so many of the incredibly complex chemical reactions that we call life. So the result was a mass catastrophe that happened about 2.5 billion years ago called the Great Oxidizing Event, or the rusting of the Earth. It resulted in the death of most living things on the surface of the planet. But some species of cyanobacteria randomly evolved to be able to tolerate the oxidizing effects of this new oxygen-rich atmosphere. In fact, they did it by pulling up antioxidants from the soil, from the minerals. And here's something that was not proven until relatively recently, and that is that cyanobacteria can actually synthesize cellulose within themselves. Cellulose, of course, is the main molecular building block of all plants. As a result, there's now a scientific theory that all vascular plants, the kinds of plants that pretty much dominate life on land, on this planet, that they may have themselves evolved from cyanobacteria that started making cellulose maybe to strengthen their little mats. So we get the first vascular plants on land somewhere around 500 million years ago, I think. And around that same time, we start to see animals starting to move up from the water, up the rivers, and onto the land in search of this new bounty of nutrients that were up here. It's funny how you can see that process kind of unfolding all over again in my little aquarium as those weather loaches crawl up into the river and then onto the land. They've in fact evolved the ability to breathe or gulp a little bit of air from the atmosphere so that they can survive in the dry season. They're from marginal places too. And there you see a snail that's crawled up out of the water to eat some algae on the surface. That's what started to really happen a lot about 500 million years ago. And with that explosion of animals onto the surface came burrowing animals, worms and stuff. And what did they do? They loosened up the soil. They aerated the soil. And aerated soil is not quite as mobile of an environment as water is, but it's still pretty mobile. Like, stuff can move around inside loose soil. Nutrients and roots and living things, they can all move and combine, and you get all of those random chemical reactions that result in some self-perpetuating chemical reactions that we call life. And the explosion of life on land really started to happen around that time. Mass evolution of all kinds of really cool plants, including all of the delicious ones that we eat. So next time you sit down to dinner to enjoy anything that didn't come from the sea, thank this yucky little sludge here, because this gave you everything. Okay, would you like a broader update on the whole crab tank project? It has not gone entirely as I had planned. So just a reminder, I did make a video about how I built this tank. It's in the description. This island is actually a floating raft made out of expanding foam and then covered in silicone sealant and then crusted with sand. And I built it to be a habitat for vampire crabs, and I got a bunch of vampire crabs and they lived happily in there for all the winter. And then when the humidity started to go up in the summertime, that's when I noticed them starting to wander off, I think as they felt more comfortable leaving the water, which I kind of expected, and I was able to scoop them up. I found them in potted plants, I found them on the floor, I found one in the driveway. I'd find them and I'd just put them back, but they'd wander off again. And in fact, that one I've been showing you in this video the entire time, I haven't seen him in a couple of weeks. They seem to form a little colony underneath my trough there. I would see them poking their heads out every now and then. One time I saw them fighting. I saw one chasing another crab out that little hole there, right there. But then I saw a skink. A skink is a common local lizard here where I live in East Tennessee, and saw that skink down underneath the trough, and after I saw the skink there, I never saw any more crabs again. I think they got. So I've been refitting this aquarium over here, this tall guy, to be a more secure vampire crab habitat. The crabs really cannot climb up the sheer glass surface. I've seen them try. They don't have a chance. And this driftwood fountain is actually freestanding because it's suspended from a chain that's going up there, and I just don't think that the crabs would climb up that chain. They might try to climb across this tube here that's supplying the water from the filter. It's a little bit smooth, and they really don't like to climb smooth things. I've seen them try, but I still think I can put some kind of like break there that they wouldn't be able to pass by, maybe like made out of aluminum foil or something slippery. So I'm going to put my new crabs in here. I think they'll love crawling around inside the Java moss on here. They need land area to walk around on, and I'm going to try to see if they'll actually walk around and live on this water lettuce. That would be very convenient for me. But I did make another floating island that I can put in there should they seem like they need it. And in absolutely no way do I consider this crab tank to be a failure. I absolutely love this terrestrial environment that I've built here. I love gardening on it, so many different cool plants. I will say that the Java moss that I was expecting to work really well did not work that well. That right there is the only remotely healthy patch of it that I have left, and you can see it getting swamped by cyanobacteria right there. So I pulled up most of the Java moss and I just replaced it with plants that would be able to grow up out of the soil and away from the algae, and they've been doing gangbusters, as you can see. And it's not just the loaches that crawl up and do stuff on the surface. Snails, as you saw, but shrimp, lots of shrimp. I will catch them up on the surface eating algae as though they're land animals, which they very much are not. I also see them over here. My little slate and silicone fountain that I built for my shrimp cube here. Yep, that's a shrimp right there who's feasting on the algae on the slate. That slate fountain worked so well that I built one over here for this tank. It's new, that's why these plants don't look really grown in yet. But I get a waterfall with that, and the waterfall helps me to break the surface tension of the water and promote gas exchange, which has been really, really good for the health of this tank, which has a lot of its surface area covered, and normally aquariums need a lot of surface area in order to be healthy. I think I've been able to make up for that with the waterfall significantly. Oh, and an update on the garden enclosure that you also saw me build in a video that is linked in the description. This has worked out okay. These tomatoes have gone relatively unmolested by small animals, but some small animals have been able to make it through the netting, and I'm starting to see some tomatoes disappearing, and look at that one. Oh, you little bastard. Honestly, I think I just have too many damn squirrels back here. I think I'm giving up on the terraced garden here as a vegetable garden. I'm going to use it as a decorative garden, and then I'm going to build some really secure boxes for growing vegetables. Somewhere up there, maybe. Oh, and the hydroponic strawberry growing rafts that I showed you, they sank. See, the wood took on enough water that they sunk just enough below the surface of the water that the strawberries weren't able to grow. And yeah, some experiments really are failures. I'm gonna try a plastic raft next time. It won't look as nice, but it might get the job done. Talk to you next time. This is what I get for considering aesthetics.